All right, so I'll get started. Today we're going to be going over how Active Directory works, and then some basics of flaws in the authentication protocol that have not yet been fixed, and how you can turn that practically into attacks against pretty much any enterprise up to date. And this is just like the tip of the iceberg. There are going to be 2 more meetings after this on going after like things like access control and delegation and such. But these are sort of the bare minimum basics that you'll be able to use against pretty much any domain. So this is your meeting flag. Slides are up. I just chose domain expansion because 1, it's funny, and 2, pretty much everything in Active Directory has to deal with the domain, right? That's your region where you're working in. Okay, so we have a lot to go over. I'm going to focus mostly on why Active Directory exists, what problem does it solve, and then how does it go about solving those problems, and what shortcomings arise, especially from how it handles cryptography and how it handles trust, because there's a lot of flaws with the ways that they're doing authentication over a network. And then towards the end, I'll give like a brief overview of how you could go through some of the stuff practically. But that's the kind of thing where it's a lot better if once you get the theoretical knowledge, you go find some like hack the box type environment and go practice. But I'll go over like the basics of how you would go and execute these attacks. They're actually very, very simple in practice. Okay, so what is Active Directory for? So if we think about UIUC as a system, right? We have 3 campuses, we have a lot of students, we have a lot of computers and user accounts that need to get connected. They're all gonna need an email account, they need access to school computers of different types and different places, and need access to different locations. So that is a lot of computers. And the question is, how do we manage them? So if we had some kind of like peer-to-peer ad hoc system, right, there would be some problems because every like individual thing could be run in its own way, right? Like imagine if each of your classes had a different standard for just going and accessing stuff and logging in or getting into your email, right? And that doesn't scale, especially when we're talking about this volume of users and computers. So the idea is we're going to have one centrally managed database that's going to store who everyone is, including user accounts and who all the computers are and who all the domain services are. And we're going to have this one place that everything cross-references to centrally manage it. That way, if you're in an enterprise, you can go through and manipulate this, right, from like your position of privilege, and you function as that sole source of trust. So AD is kind of a couple technologies put together. It was introduced in 1999 to merge LDAP, which is like your database of like your relationships, Kerberos, which was the authentication, and DNS, which is like locally who's got what and where, because Active Directory will have its own DNS resolvers that are separate from the web. But the main protocol when you think Active Directory is LDAP. LDAP is how you query to figure out, hey, what computers are on this domain, what users are on this domain, who has access to what, right? LDAP is the thing that stores all of that. It stores your security policy. And if we didn't have anything like this, we'd be connecting computers in a way that's like totally ad hoc and decentralized, and enterprise management would be basically impossible. Like imagine if you had to trust all your friends with passwords or SSH keys. Like that would totally not work. However, having one sole source of trust for 100,000 computers is also very, very dangerous, because if you can compromise that one sole source of trust, well, now you have the ability to go take over every other computer on the domain. And this is what we'll see a lot of Active Directory compromises look like, is for pretty much any kind of attack, the attacker will be trying to get as many privileges as possible, right? And just beelining their way to taking over the domain. And then they're going to use that to do whatever their objective is. So Active Directory is a system for a bunch of computers to interact with one another. Now, what will happen is you'll have a domain, and your domain is like the sort of thing that envelops this organizational structure. So an example for UIC would be illinois.edu. That would be your domain. And then each domain will have a domain controller. So when I'm like, hey, like how many user accounts are there at UIUC? Well, I would need to go query the domain controller for illinois.edu. So this is your centralized source of truth for that domain. And the domains are laid out in a tree structure, right? So if I were to have some subdomain of illinois.edu, that would be called a child domain. And what's interesting about this is child domains will have their own domain controller. So the children and the parent will trust one another, but the child is like at a lower sort of level. So if you go forward to like something like this, for example, you can see we have our top level domain here, which is the root domain controller. And then you could have two other domains, right? And they could run things very differently, but at the end, each of them will have their own domain controller, and they'll all connect up to the root domain controller. And each, like, these two subdomains can manage things differently, right? And they can not talk to each other or interoperate with one another if they don't want to. But someone who is like a max tier admin of the top domain would be able to get down into either of those domains, if that makes sense. Okay, so one last thing that's important to note about Active Directory is when you have a bunch of computers networked together, that requires a degree of trust. And there are things they do to try to make this as robust as possible, but it's just not enough, right? Because you have computers that are interacting with one another and giving them abilities to do things to each other. And you can chain those together, because that's by design, it's not a vulnerability. And a lot of times, like we saw with the Windows privilege escalation, you can get things that are way more than the sum of their parts. And that's where you're going to get a lot of your vulnerabilities from. A common method would be trying to go from an unprivileged user and escalating your privileges up to a domain administrator. And Active Directory is permissive by default and very hard to configure correctly. So even if you have a skilled security staff, like there are tons and tons and tons of areas for this to be misconfigured. And every time that happens, you could be creating, a toehold for an attacker to be able to escalate up and potentially get closer to their goal of becoming a domain admin. Okay. So the main thing that runs Active Directory is Active Directory domain services. And you could think about it like there's no magic here. The domain controller is just the server that runs this service. And every time a user is like, hey, I'd like to log into the Illinois domain, right? Let's say you go up to like a computer like this one right here, and I'm like, I'd like to log in with my net ID to Illinois. So I'll put my stuff in here, and it'll go query the domain controller. And it'll say, hey, domain controller, I'd like to log in. And it'll usually be using a protocol called Kerberos, which I'll go over in just a moment. And the domain controller will be like, okay, sure, you're giving me this cryptographic evidence. I'm going to go consult this big database I have called entities.dit with all of my user accounts and all of their hashes, and I'm going to go check with all of my STDLs and security policies. Be like, can you log in? And if it's yes, it'll be like, sure, here you go. Here's your logon session to the domain. So that database is what manages your ability to do pretty much anything, to be able to log in, to be able to remote into certain computers, to have access over objects in the domain, such as other people's accounts or other computers, or even services. And the security check for this, if you guys remember from last time, is STDLs. They're really big and nasty because there's no abbreviations. Like before we had like OA, for example, and it'd be like, oh, some kind of like organizational admin. This will be the whole SID of the entire domain. So these are very large, but it's still, at the end of the day, the exact same access control mechanism that your normal Windows OS is going to be running. And just like you had SIDs for your users and groups on the individual computer, you will have SIDs in Active Directory that are going to be referenced by the domain. So it is a very similar method of how it's all run. So I hinted at this before, but one really big problem with having a sole source of trust and one database that runs everything is that if you can compromise this, you will own every single computer and every single user account in the domain effectively forever. There is no meaningful response, and I'll get into why this is later, that will allow a business to realistically rebuild their domain if they get a full domain compromise. They basically need to just start over from scratch, which makes this super dangerous.
If the domain was configured correctly, would it be impossible for someone to attack it?
That is $1 million question. Even if your domain is configured perfectly, it is possible to have 0 days. But in practice, from what I've seen, right, and I'll show this later because you can like chart a path, like how many hops it takes to get to domain admin. Usually those will only get you about 1 hop, right? So you would need a lot of them. In practice, though, I have never seen a perfectly configured domain, even when there's very, very smart and professional people running it. And that's because, in my opinion, running an Active Directory domain is really hard, especially at scale. And there's some things that Microsoft does with like legacy things. I'm not going to get into today, but like SCCM, if you go Google that make it really, really hard to do this right.
So it's not just domain configuration that's really hard. You have to bear in mind that this is not just a network of computers talking to each other. This is also a network of people, right? So let's say you fished one of the employees, you go to their Facebook page, found out who they are, right? And then ask him for his credentials, and they actually give you through some mechanism, right? And then you can impersonate as this employee to go to a boss and be like, hey, I have this project on hand. I need to be like an admin of some kind, and then you can go from there. So many times in real life, a domain compromise is not just a compromise in the configuration, it's also compromising people, and therefore all the machines.
Yeah, that's a fantastic point. A lot of times when you're trying to like do a chart a path of how do I get to domain admin, you fill in those holes with exploiting people, because you'll notice a lot of times people are much more permissive with things they're familiar with. So imagine if you're on a work computer, right? And you can go put a little piece of like malware that steals credentials in a publicly accessible folder and name it something really eye-catching, like classified, do not read, or employee pay spreadsheets, right? These are classics we've seen in actual breaches. Then folks will go and click on it, not knowing any better, even if they're technically competent, because someone here at my work put this here, so they're probably somebody I know, right? And you open it up and you've been compromised. They'll let you do another one of those hops. So, what's up, right?
Why does a compromise means like compromise forever? Like, why don't,
I will explain that later on when I get into how the cryptography works. It's a cryptography thing. I'll leave you in suspense. Maybe you can figure it out while I go over it, because it's actually pretty complicated. Okay. And I went over this a little bit before, but this is like the piece of software that everyone uses, right? Like almost any big group is going to be using this. So if you can master hacking this one piece of software, which is not that big of an ask, all things considered, you're going to have knowledge you can apply to hit pretty much every organization, right? And this is a big deal because there's not a lot of difference in how one AD domain is configured versus another, right? Like if you have something that works, it's going to be pretty much guaranteed to be adaptable to any AD domain, unless you're doing something like really, really exotic with two-factor authentication.
Also, Ronan, I think you're going to agree with me on this, but configuring it properly to make it work is harder than hacking it.
That is, yeah. You're not wrong. At scale, that is, I think, arguably correct. Yeah. Okay. I put a lot of effort to make this slide look cool. Because now I'm going to go drag you guys through cryptography, everyone's favorite. We all love cryptography. So Kerberos is the main way you're going to authenticate in Active Directory. They also support NTLM, and I'm going to go over the protocol level flaws with how does Kerberos work and how can we attack it, and how does NTLM work and how can we attack it. And then if you have that, you have the majority of ways you'll be able to authenticate in Active Directory, unless you're going after asymmetric cryptography systems, which I'll go over in 2 weeks. Okay. So Kerberos is a whole different paradigm, if you guys remember NTLM a little bit from last week. This is another sort of zero-knowledge proof, where you're trying to prove that you know your password without revealing it to the verifier, because this was around before SSL was mainstream. That's how old Kerberos is. So it needs to be handling a lot of the mutual authentication like in and of itself. So you're proving your identity via cryptographic keys derived from passwords. And like a really dumb, but like good to remember mnemonic is that Kerberos will give you tickets that let you do stuff to things, right? And that's kind of like a tongue-in-cheek way of making you remember that. Because NTLM, you just have this like magical hash, right, that lets you hop around to places. But Kerberos is about your right to do stuff to things, as in, can I modify a service? Can I log into a computer? Can I create a user, right? That's sort of the Kerberos like mindset. So it's much, much more fine-grained. So Kerberos is a 6-step process to log in. And there are going to be multiple points of failure in this process in terms of how trust works. So you're going to have your authentication service, which is the dog here. And it's going to know all the passwords, because in practice, this is your domain controller, right? It has your ntds.dit, knows all the passwords. So, your client's like, hey, I want to log into that service over there. This is something I need. Let's say for my work, I need to go log into it. So you're going to go send an authentication server request, and you're going to be like, hey, authentication server, this is me, this is where I'm from, and here's something to prove that I am who I say I am, right? And then the server will be like, okay, well, if you are who you say you are, I'm going to give you back a little encrypted blob that only that real person can read, because what they're doing is they're doing public key cryptography, where the keys are going to be derived from that password. Both sides know the password. So you're using this like a signing mechanism. And then the server will send back a TGT, a ticket granting ticket, that is encrypted with the server's hash, which is interesting. That's not the client secret, and a session key that the client can decrypt, right? So if we're tracking what's being used so far, there's the client secret with the ASREC, and then in your ASREP, there's going to be something for the client, and then also something encrypted with a server secret. So this is going to provide mutual authentication between the client and server, just due to like that public key mechanism. And now the client has what's called a ticket granting ticket. So basically the way this works is you don't actually directly go from the client to the service. You are instead going to authenticate to the authentication service as your service, and then use that to get to the service, which is a little convoluted, but that's how they have it set up. So one really interesting property of this, because I said, hey, the whole premise of Kerberos is that you have this granular permission that lets you do stuff to things, right? Well, already we kind of break that promise by having a TGT, because a TGT is service independent. It authenticates you to the thing doing the authentication. And that means functionally, right, we can do very similar things to an NTLM hash. That'll be a lot clearer once we go through all 6 steps. So, with the TGT, it's like, okay, I have a TGT. The client's like, I would now like to access that service because I have this ticket that proves to you I already proved I am who I say I am. The client's like, this is me. And the server's like, sure. And then you get this ticket, your ticket granting ticket. And they're like, okay, server, give me a new ticket for that thing over there, because I can't log into that thing over there with the TGT. The TGT is your service ticket to Kerberos itself. So you're going to send a TGS request. You're like, hey, authentication service, I would like that ticket. Here's my current ticket. Give it to me. So a TGT is a TGS to Kerberos itself, right? And the TGS, if you think about the mutual authentication, its secret is the thing you're authenticating to. So it should hopefully make sense then that the thing you're authenticating to is Kerberos. So the Kerberos, secret is going to be in this TGT. So if that goes through, it'll send back the TGS rep, where the server sends your ticket to that service, and it's encrypted with the service's hash, and then a session key the client can decrypt to go log in. So that's a lot, right? We're not even done, and we've already dealt with secrets from the client, secrets from the server, and secrets from the service. It's almost like there's 3 secrets to go to the 3 heads on the dog. Wouldn't that be cool? So yeah. And finally, this is like a standard login. The client now has this piece of authentication material and they say, hey, service, I can log into you. And here's the session key. And the TGS will look at it and be like, okay, what access do I give you, and give it to them if it's legitimate, right? So 5 and 6 are like about what you would expect if you were designing a normal authentication system, right? 3 and 4 are as an intermediate step, which is your pre-authentication to get that TGT to prove identity. So there's something really interesting that'll happen if you're missing it. Sorry, what's up, Henry?
No, like, I guess you want to go to the next slide, and then
Yeah.
I want to.
Yeah, sure.
Yeah.
So when I said AD is hard, right? Like that is very convoluted, even for me, and I've been looking at this for like 2 years now. So can anybody immediately see a problem with this? I do not expect you to, but you might be able to if you think about how the secrets are handled.
So the first one I'm confused about, when they exchange the TGT for the TGS, can they ask for something that hypothetically only their teachers can ask for?
The TGT will only give you things you have a rightful access to, if that makes sense. The TGT is like an NTLM hash in terms of power. So if you have like your set of rights, and you're like, I have this ticket granting ticket, that'll still only, like, even though it's a ticket that grants tickets, it'll only give you tickets that you actually like deserve. I can't be like, here's my TGT, let me go log in as my professor and go change my grade, right? I would need to have that access control in place. What the TGT does, it says, hey, I can go present this to the authentication server at any future point and be like, let me into that thing I have rightful access to. That's what the TGT does.
You intercept the TGT. You sort of can use that to farm TGS.
So if you have it, yes, I don't think you can intercept it over the network. You can pull it off of the computer. If you're logged in, you can rip the TGT out of memory. But remember, this is using like public key cryptography, essentially. So you're not going to be able to go pull the TGT contents out unless you have the secret. And if you have the secret, well, then you can go request a TGT anyway, if that makes sense. That's like the threat model. Yes. Yep. That is a very difficult question. In fact, much harder than you would think. The correct way to do it, you go through and start revoking their ability to go do this. Like you give the TGT less rights. There is one persistent problem that I'll go spoil in like 3 or 4 slides that shows why that's harder than you would think in the event of a domain compromise. If your domain isn't compromised, then all of these have an expiration time. Like your TGTs will go away after a while. So you would just cut down the access and sit and wait. Yeah.
So if the TGT ticket has to be transmitted from the domain controller to the client,
Yep.
you should intercept it there.
You would need to decrypt it. You would need to know the client's password. And if you have the client's password, you can request a TGT. If that makes sense, right? So there's like some credential alchemy you can pull with Active Directory, but if you have the clear text password, you can either get a TGT or an NTLA. Yeah, you could basically do it. So that's the threat model. So the actual encryption of it is mostly secure. I will say mostly. It's not fully secure, which I'll get into. These are all very good guesses. You actually hit on something very important, and you hit on something very important. So
can I
yeah.
just get a moment? So I mean, if you think about this is partially social commentary, I guess, but also like, you know, to make you guys understand it better. You can think of the client as a person that's born in the US. And the first step is to get a birth certificate. The second step is to get an SSN. And then the third step is to go to the bank and request a bank account. Because the first step is proving, okay, you know, I am a client, I have password, right? I have all the metrics, please, you know, give me a thing that proves my identity. And then the second step is I would like to access some services, for example, banking, please give me a number that identify myself to do that, and then present to the service, which is the bank to do that. So hopefully that's about the same 3-step process, right? But the one problem with giving people numbers or IDs is that they don't get rotated. So imagine you're reusing the same TGT for every single service and access here. Well, I mean TGS, right? Imagine you're using the same thing to hear multiple times. What if the service is compromised, right? So if the bank is compromised, your social security number is now exposed, and it's kind of a mess to replace it. So what I'm saying is that we should have a system where you present yourself to get a one-time token that you can present to the banks to prove their identity, and this way your number will not be released. But in any case, authentication is cool, and now you know a real-world application for it, I guess, and how you can model real-world systems with authentication.
Yeah. So now we're going to start breaking shit, which I think is what everyone is here for. So like for each of these 3 heads, we're going to go over 3 things that are like, you know, supposed to be secret and how we can sometimes unconditionally get into them, sometimes conditionally get into them. So your TGS, and this is like the most famous Active Directory vulnerability to my knowledge, is that we can just abuse where the secrets are coming from. So, you know, a TGS returned by your Kerberos, right, your authentication service, is encrypted with a secret derived from the password of the account that runs the service. So let's say I have an MS SQL service account running an MS SQL database, you know, and let's say it's open for anyone to go at least like connect to anonymously, right? Well, what I can do is I can say, hey, I'd like to connect to this, even if I have no interest in connecting to it, and go get its TGS. And then I'm like, huh, I'd really like to know the password of that super secret database account so I can go in and steal everything in the database. So you'll fire up your GPUs and say, try every password. And if you don't have a strong, like really strong domain password policy in place, this will get you owned immediately, because this is not like a brute force where you send it over the network again and again and again. I make a normal connection, I get a legitimate TGS, I go home and put it through my GPU farm, and then I try every single combination of passwords I can think of. And practically anything under 12 letters is going to get compromised. So this is something that'll let you, as soon as you have any valid domain login at all, you just need one account where you logged into the domain, and you can start pulling TGSs. And you can imagine it'd be very, very easy to just in one shot pull every single TGS from the domain, and then in parallel start cracking all of them. And if you have a domain with 1,000 services, which for 100,000 computers is actually a fairly conservative estimate, if even one of them is vulnerable to this, and you're gonna be able to get into that, attack everyone that's connecting to you, and potentially keep working your way up the domain. And that's twice as bad if it's a privileged service. I think, Anthony, you raise your hand first.
So I'm guessing that hash thing is like not a good hash. So I know like there are some hashes that are designed to be like very slow. That force is hard, or that practice is hard.
Yep.
You know which hash?
This is an important subtlety. They have multiple supported protocols. The main ones I can think of, and it's weird, it's like a hash, but it's technically encrypted. They had RC4 was the old one, and now it's AES-256. AES-256 is slower, but it's not appreciably slower to defeat the attack, if that makes sense. RC4 is a legacy encryption type that will still be used a lot in some contexts, but not all of them. If you can get a TGS on RC4, then yeah, you're in business. If it's AES-256, you can still do this, but it will be slower. So it's really complicated which ones they use, and that's going to depend on how modern your domain is. The new canonical way of doing it is AES-256. Chris, do you have?
Yes.
Yeah.
So to get a TGS, don't you already need to have access to the service according to?
Yes, it can be like totally unprivileged access, but you need to be able to at least get any kind of access. A lot of times, though, in practice, right, it wouldn't be like I have the ability to remote log in. It would just be like permissive by default, I can connect to it. So there will usually be, when you compromise any one user account, a bunch of these, like a very large number that you can go do it to. It's that's why I said it's permissive by default. But yes.
Correct me if I'm wrong, but I think that for MS SQL, like the actual access control is checked on the MS SQL side. So if you are any person in the domain, when you connect, the fact that you can connect means that you have gotten the TGS. And then the MS SQL then see, okay, you're not on the list, you're denied access, and then it's gotten back to you. But in this process, you're still allowed to connect to the server by the Active Directory domain controller, and therefore you can get the TGS.
So what you're trying to use this TGS for is to hack the password of MS SQL.
Yes, and then I can log in as database admin.
Because of how it's flawed, because the TGS is encrypted with the...
Yes, think of it like a password hash, right? So I can snipe that over and then try to crack it. So in practice, the way you defeat this vulnerability is actually fairly simple. You just have super strong domain password requirements effective immediately. Like if you have like 30 characters or whatever for your service accounts, you'll be okay. Yeah.
How does this actually know if TGSs are legit when it's the authenticator that issues the TGS and the service doesn't actually talk to the authenticator in the diagram?
So if you think about it, right, TGS is encrypted with the service password. Who knows the service account's password? Itself and the domain controller.
Yes.
So if you get the TGS and you can decrypt it, you know, A, it's genuine, and B, someone else must have crafted that for me. And the only other person that knows the service password is the domain controller.
Oh, okay.
Yeah, so this will be a little complicated if you don't have like a theoretical background in like asymmetric cryptography. But yeah, you're basically providing your authentication and legitimacy by knowing who knows what secrets. And that's why we had that big, annoying multi-step flow.
But of course, if you have a dumb sysadmin that put like the service account's password in plain text or in a spreadsheet, then you can afford it. That is a thing that you could do, but usually you can just also log in that stuff.
All right, so I'm going to go into the next point of failure. This is the one where I was like, why is the domain so hard to rebuild? Well, if you recall, when your TGT is your TGS to Kerberos itself, right? And it's going to require that service password. Well, the Kerberos account hash, as it turns out, is not supposed to get rotated or changed. And you see, this is what we use to go prove our access to anything else. So if we compromise the domain controller, which is running Kerberos, we can get the Kerberos hash, which is a problem because that means I can make any TGT I want. So I can go basically use this to make a ticket that says, yeah, give me all the access to all the things, right? And well, how would we kick someone out? Well, that would require rotating out that Kirby TGT, that's your Kerberos ticket grading ticket account password hash, which is not supposed to happen. That would, I think, generally require a full domain rebuild. Because if you think about it, when you join a computer up to the domain and hook it up for the first time, you're doing your mutual authentication with this. So when you rip that out, I haven't tried it myself, but I'm pretty sure you would like force disconnect most of your domains. I wouldn't trust one another anymore. So this is why getting into a domain controller is like such a dangerous compromise, because once you get into the domain controller, you now hold every secret necessary to go get all of the control over all of the things forever. And that is just how Kerberos works. Like there is no patch for this. That is just the nature of the Kerberos protocol. So this is a very common post-exploitation step we see with APTs when they go get in and get domain compromise, is they'll do something like this.
Is there a way for the service to know it's been compromised if you like don't do anything malicious?
No, which is what makes it super scary, right? Because if you can just tiptoe up and get your way into this one machine, this domain controller, yeah, you can use the feature of like how the secrets are managed to log in legitimately and take over everything. Yeah.
I'll also give you an example, right? Let's say these hashes exist in that same exist in that place, right? So instead of reading the file, what I can do is I can have another computer say that I'm another domain controller in the system and require a synchronization, but that computer is under your control. There's a protocol for this because for redundancy purposes, right? And then if you synchronize, and then the other DC is going to be like, okay, I'll synchronize with you, and therefore transferring the entire ntds.dit, and then you get it, right? You don't actually need to read anything from the original domain controller to get the file. So there are many protocols. There's even a VSS, I believe.
Oh, yes. Yeah, man, that brings back memories.
Many synchronization services out there for people's convenience that you can abuse, right? So you don't actually have to directly read the file. And some of these are signatured by defense mechanisms, but
guess who runs your defense mechanisms?
Yeah.
Active Directory. Yeah, so you can go in and just turn them all off, right? That wouldn't be very stealthy, but you could do any number of things to go render them like disabled. Yeah. Okay. This is, I think. Oh, sorry. Do you have something? Yep.
Then do they usually like rebuild everything, or
So the domain controller is a machine. Your domain admins are guys who have the power to manage the domain controller. So you could go revoke all the domain admin access, right? I am fairly certain there is no legitimate use case in which a domain admin could recover the Kirby TGT hash without using some kind of hacking tool. Maybe you're really, really clever and know something I don't for like legit sysadmin, but like the only thing I could think of would be making like a volume shadow copy backup of the NTDS, and that's like still totally malicious. So the idea is you have a user account for this, and then when they're done, you just purge it, and that'd be the idea. Okay, so this is the only one. There's actually some precondition, and it requires a domain misconfiguration. This precondition will happen sometimes when Kerberos is being annoying, which, trust me, you'll know it when you see it. So, use a TGT, and that's your pre-authentication to prove your identity, right? So if you're like, I don't like this TGT business, let's not do the TGT. Well, the problem with not doing the TGT is that anyone can request the ASREP, and that uses a user account like secret, right, to go do that. So just like we had the Kerberosing vulnerability, there's a little box in, I think it's your, I don't know if it's group policy or the Microsoft Management Console. It's one of them where you go to your account, and you tick this box and it says, don't require pre-auth. And this is usually used for service accounts, but sometimes it's used on people too. So what you do is you go request the ASREP, and then you just crack it. And practically, this is a very simple attack to pull off because you can just do one LDAP query and see, well, who has this set? And then for each of them, just request the ASREP. So this is very similar to the Kerberoasting vulnerability. But this one is not going to happen by default. It requires a misconfiguration. Okay, so that is it for the Kerberos protocol, which I know is a lot. Does anyone have any like final questions on Kerberos or any of these attacks before I move on to NTLM and NetNTLM? Yeah, so.
So once you like crack like a domain admin and like get domain control access.
Yep.
How do you like work your way up to the root?
Oh, I'm going to cover that later. That's actually very complicated. So when you're a child and parent domain, they have what's called a bidirectional trust, which means the child and the parent trust each other. In which case you can use, I believe, the DC sync thing that Henry mentioned to do that. There's a thing I'll cover next week called unconstrained delegation, which you can abuse to go basically get access via TGT to the other domain controller. If they're in forests, though, that are joined together, let's say Illinois.edu and some other thing like Amazon Web Services, then your trust only goes in one direction, and fully compromising one of them will not let you get into the other. So it's actually quite complex. You can assume in any case the child can always compromise the parent and vice versa, but forests are considered a security boundary, if that makes sense. Yeah, so the technique to do that hop I'll cover next week.
If the password is secure enough, will they not be able to crack it?
Correct.
Okay.
That's correct. So if all of these crypto vulnerabilities can be solved by having like a really annoying password policy, which I know sucks. It's like, why do I want it to be like 16 characters and they're all randomized? Well, it's because of this. All right, cool. NTLM. NTLM is just worse than Kerberos, and you're about to find out why. So this is some review from the Windows portion because I want to make sure this is a very important vulnerability to know about if you're going to be like a hands-on keyboard like red teamer. This is something you're going to see all the time. So if you recall, NTLM is another sort of like flawed zero knowledge proof type thing, where the hash is the authentication material, not the password, which is a problem because that means stealing the hash is equivalent power to a password that I can prove to everyone else on my network that I am the person in question. So imagine if being able to read the shadow file on Linux let you become everyone in the shadow file. That's a problem because now there's no cracking step. You could have the most secure password on the planet, and if I could obtain your hash, I can just become you. Like that is a serious flaw because you used to be able to just go read all the passwords on your machine when you had like system privileges. So the way this works is like not nearly as fancy. It's just a challenge response protocol where in your response you prove that you have some knowledge of the hash, and it's frankly not that important. So this leads to one of the most common legacy techniques for compromising Active Directory, which is that there's a process called LSAS, which we went over last week, and it's like your Etsy Shadow, but for Windows, and it runs a service. So it's a process you have to get into memory. And then what you do is when you have that system account, you can do a memory dump of that process and obtain all of the user hashes. So there's a tool called Mimikatz, which is very popular. It's like the most signatured piece of malware ever because it was so ubiquitous. And they just had this command, secure LSA, log on passwords, and it would dump all the NTLM hashes from everyone logged on to the box. And this wouldn't just be your local user accounts. This would be if you're an Active Directory person and logged into this. Like if you had somebody else logged into your computer, then you would be able to go read their hash, which is a huge problem because that means I could prove to everyone on the network in that domain that I'm them. Now, there is a modern mitigation to this called Credential Guard, which basically removes the ability to go read LSAS process memory. And that is an optional feature of Windows 11. In my experience, it is on almost every workstation and almost 0 servers that I've seen anecdotally. So this is the pass the hash attack. So suppose we've gotten system on a box and we've dumped LSAS memory. And we see like a user's NTLM hash. We don't have their password, but we have their NTLM hash. Since NTLM is like a proof, I can prove to anyone else that I'm them because I have the secret that they use to prove that's who they are. So the issue is we can become anyone whose hash we obtain. So when Henry's talking about human factors, right? Like there's normal cases where some person would just be logged on to another machine, and then by compromising that machine, you could become them and log on to wherever they belong, right? You could also be considerably more evil and be like, hey, I need like a tech support. Like, can somebody go fix this? Can you go remote into my computer? And then some guy who can get TTSs to remote into all of the normie computers logs onto your box, which you have system on, and then you dump their NTLM hash, and now you transitively can prove, hey, I'm the IT guy. I can go in and fix all these people's computers by logging in and backdooring them. So this was a very, very common method of attack before Windows 11. Now, doing this on Windows 11 requires both a kernel exploit and a hypervisor exploit if you want to do it without doing a lie in wait, where you like sit and wait for people to log in. If you are okay waiting for a log time, there are ways to backdoor LSAS. I'm not going to go into that here. They require tedious kernel programming, which I think there's very few people in the room who think that's a good time. I actually enjoy doing that kind of attack, but doing this on Windows 11 is substantially more complicated. So while curl roasting and stuff is still around, this has been reduced quite a bit. But here's the idea, right? So let's say I root a Linux box, and I know I have some user that's shared with SSH access into the target, but all I have is the hashes. Well, now, because I'm authenticating with a password in the Linux system, if I can't crack that password, I can't SSH into the target, right? But for Windows, once I get system and I get all the hashes, well, I don't need to crack it. I can just prove to that box over there that I am the person who rightfully owns this computer and whatever. This is how you're doing your proof. So Credential Guard does not fix this vulnerability. It just says no hashes for you, which is interesting. That's kind of been, I think, the model we've seen with Windows, where they're more focused on preserving functionality, right? And it's much easier to go stop the ability to get hash reads than it is to redo the entire NTLM protocol. And NTLM has been slowly attempted to be phased out for like the better part of a decade, but it is still present everywhere. And due to backwards compatibility features, you can actually go in between NTLM and Kerberos. So yeah, does anyone have any questions on the theory of what the pass the hash vulnerability is? I hope this one is much easier than Kerberos. All right, cool. So practically, if you want to do this, it would only work on like Windows 10 and earlier, but you can use a tool called Mimikatz, and that'll go read out the process memory. Some interpreter has this built in as an extension. You can use a module called Kiwi or hash dump to go do this. You can use it just as an exe off of GitHub, and that's how Mimikatz works. An exe, you put it on the target, you run it as system, and you go pull down all the hashes that are on that box. Secret Stump is interesting. Secret Stump tries to steal as much as possible while not executing an agent, and it reads everything from the registry. Now, there's a couple caveats with this. The first is registry is only going to have your local accounts. They're not going to have Active Directory accounts logged in. They will have something called domain cache logon information, which is like a hash. Even though you can crack it, it is so computationally expensive, you will likely not be able to. So Secret Stump, though, Credential Guard does not do anything to stop Secret Stump. Like every bit of information listed here, you can go pull off of that. What will practically win you some access with Secret Stump is if somebody has like one of those autofill passwords, and you have it for like saved RDP connection, or you do password reuse, it'll snipe all those up. So like think like stuff you would use in your browser or whatever. Secret Stump can pull that sort of thing, but it cannot get you the Active Directory hashes like Mimikatz used to be able to. Okay, so that is NTLM. Now I'm going to talk about net NTLM v2, which is functionally like think of it like a fork of it that does the exact same challenge response, but there's one big caveat. Net NTLM v2 cannot log into the computer that sent the hash, but it can log into any other computer on the domain, which is a strange property. And we can try to crack this to recover the plain text password. It will work sometimes. It's about 12 characters or less. But what's interesting about net NTLM v2 is that there are a lot of things that will automatically force a net NTLM v2 logon. This is considered more acceptable because you're not getting the straight NTLM hash, right? This is just the challenge response. So if you can trick someone into visiting an SMB server, Windows, because it's nice and convenient and wants to help you, will automatically log you in and will send that net NTLM challenge response. So they're like shortcut files, which can point to any file on disk, And what's cool about the Windows file system, we can point them at other computers over SMB. So what I can do is if you have like some shared drive in your organization, or if I want to send something to you, like, hey, here's a shortcut. You know, it's a shortcut, right? We can make it look like whatever we want, have some kind of icon, be like report.pdf, whatever. And then you click on this and it'll automatically log you into the attacker server. So, you know, a common fish you could do would be to go host shortcut files that point to a legitimate file, like on an attacker SMB server. You click on it, you get a real file out of it, so you think everything is okay. But actually, by obtaining that file, you will have transmitted over some sensitive authentication material. But you know, phishing is kind of lame. We can do better. How can we do better? Responder. So Responder is a network man-in-the-middle poisoning tool, where, you know how I said we're gonna, you know, automatically log in by visiting these SMB servers? Well, what I can do is I can say, hey, when you look up a DNS name, say google.com, you're supposed to go to your DNS server, right? But Windows, ever so convenient, will first query your local network. So I can go on your local network and basically start poisoning every single method of doing queries, which would be DNS, LMNR, and WPAD, I think, and send out. So when you mistype, you're like, I'm going to go to goggle.com, because I mistyped it. Who's goggle.com? That's me, right? And what'll happen? Well, if you try to visit one of many different types of resources, because Responder will spin up web dev servers and certificate servers and SMB servers, right? And if they visit any of those, just by having a typo, you will obtain their hash. This is like as illegal as it gets. Like if you were to hop on Illinois and be like, I'm going to start running Responder, you are going to get swatted, because this is super obvious. You are poisoning all of the things, right, in every direction, but it's super effective. If you are looking to go get domain administrator, like, you know, before lunchtime, this is a top tier tactic. Just plant that and let it beacon out and see who you can get out of it. And that is because of another vulnerability I'm about to go over that you can combine. What's up, Bray? So this is not going over to HTTP. This would be for alternate things like SMB. So imagine if you go to like your Windows like file share, like I'd like to go look at local computers on my network, it would be stuff like that. This also does some wizardry, which I have not looked into, with the web proxy auto discovery protocol, to poison that in a way that's not detected. I have not looked through the source code to know how it does that. I just know that it does do that. It's not like a magical tool by any stretch, but the amount of folks that will click through to one of these is very high. The other one that doesn't rely on poisoning or phishing is a bug class called authentication coercion. This is a really interesting bug where you can force a remote target to log into somewhere of your choice. So there used to be a very famous one called the printer bug, where you could do this if they have the print spooler service running and they'd be like, hey, I'd like to connect to a printer, and you have it connect to you over SMB, and you would go grab something like that. So there are still a couple of these around. I haven't like done like tabled out which ones have been patched, which ones haven't. I think Petit Patam and Printer Bug are the most common. And the question is now we have man in the middle, we have authentication coercion, we have phishing. Can we put this together to bypass the property that I can't log into the sending machine? And spoiler, the answer is yes. And this is one of the most classic attacks on NetNTLM. So if you remember, everyone else respects the NetNTLM v2 hash. So what we can do is we can be a man in the middle and basically intercept it and pass it back and forth.
Yeah, sorry, just interrupt. Just to make it clear, right? NetNTLM v2 is a challenge response. That means you cannot just use it as NTLM. It's not the sole source of truth as you. Rather, it's an authentication attempt. So I don't think you made that clear, but we could still absolutely crack NetNTLM v2. It's crackable, but relaying it is often more economical.
Yes, and this is because in practice, this is very, very easy to abuse, because there are a lot of features where if you're in like one machine, you want to get into another, you can use this kind of attack. And there's a tool to do this for you called Impact and NTLM Relay X, where you just point it and it'll automatically redirect it. And this is the idea, right? So if you remember that point protocol where it's like, hey, I send my challenge, whatever. This we just go in between. And we are using an NTLM v2 hash from something else, or we could take it from the source and then send it back, and then send it back again through us to basically do the challenge response against the sender. You can also use this in networked context. Like imagine you have two servers that trust one another and you don't have either of their hashes, and you can get on one and do an off coercion and then steal that material and log into the other. And then you can use your login in the other one to log back into the original with the exact same material, right? So this is a fairly complicated situational thing you can do, but there are a lot of cases when it comes to exploiting services, especially databases, that this will do the trick. And you can I'm going to go over MS SQL like in 2 weeks from now, but you can combine this with linked MS SQL servers to very easily compromise all of them. So I'm getting into more hash relaying later, but it's very much worth knowing about. So lastly, I'm going to speed run through the practical side. The main thing is the theory is much harder than the practice for a lot of these. If you're going to try to do this for real without being caught, that's a whole different ballgame because you need to know compilers, kernel development, detection theory, forensics, this, that, and the other thing, right? But if you're just going to do it like in a lab, it's not too bad. So we always need to figure out what is on our domain before we just start attacking. It's not good practice to, as soon as you get a login, to start curb roasting things. So kind of like whenever for network security, web security, we need to actually understand what our target is before we do anything. And it is really easy to detect curb roasting via honeypots. And the idea is quite simple. When you do a curb roasting attack, by default, you're going to request the TTS for every single service. We can just make a service that nobody ever logs into intentionally. And when someone requests a TGS for that, we know there's some bad stuff going on. So that's the idea. So you're going to want to go through and do some manual recon. And you can do this manually. If you don't care about stealth, there's some really cool stuff you can do. I'll give it a couple slides to automatically recon everything, because you just send out the LDAP queries to say, hey, who's what and where, and you can recover all of the relationships. And the main tool to do this manually is something called SharpView, which you can find on GitHub. This is a cheat sheet. You don't need to memorize any of this. I meant this more as a reference of some things you could look up. So you can get information about your domain. You can see, are we in a forest? Are we isolated? We can list all the users. We can get all the computers. We can get all the groups and the GPOs and these things. The issue is, at least, in my opinion, I think a lot of people's opinion, having all this information in a table view is really hard, right? And like picturing relationships in a table is difficult. So there's this really cool tool called Bloodhound. Bloodhound is not stealthy because it will query everything to go build this, but the premise is amazing. Where, I've been teaching you guys about like some of these attacks. Bloodhound is a map of every known Active Directory vulnerability. Those are edges. It will find all of the things in the domain. Those are nodes. And then we'll run Dijkstra's algorithm to, with every vulnerability we find, speed run us the shortest path from where we are now to wherever we want to be, which is usually domain admin. And you just run one exe, it'll auto ingest all the data, and then you upload it to a Bloodhound web server, and it'll automatically map this out. What's up, Suchit? You're going to find the guys who wrote Bloodhound are not algorithms people. This is why it requires 250 gigabytes of RAM to run it in an enterprise environment. I don't know. You can go submit a pull request if you want. I don't know. This is just what they went with, at least according to the initial 2016 talk where they demoed it. I have no idea. It's built in Java, dude. Like, it's not the cutting edge of technical mastery, but it is super cool. No, it's just, does the path exist at all? Yeah. We're just seeing, is there a path? So a lot of times what you'll see, even though it's really nice to have one connected path to domain admin, a lot of times you'll get these little fragments of like one can hop from here to there, right? And we fill in the fragments with things that Bloodhound can't map. Like, for example, you can get stored credentials out of like, people's browsers and check for password reuse, or you can phish folks, right? But this will get you even a bunch of little hops. So for example, if we look at this one, we have a SQL service and they have a write DACL access over another object, right? What this means is SQL service is a member of this group and this group has write DACL on that, so we can go hook over to them. Or we have another edge, which means we can read the password. And then if you're lucky, and this is a stock photo I pulled, because I don't have any saved Bloodhound graphs of my own, but this is an example of what a more complete chain would look like. You start as like, let's say we compromise one of those users on the left. Well, looks like all three of them are members of a group. There's admin over a box, and then in that box, there's another admin that's a session on that box. We steal their credentials and then pass the hash over there. And there's another thing to pass the hash again and become a domain admin, right? So that's the idea. Figuring that out manually would be really, really hard. So having a piece of software that will do this when you have your thousands and thousands and thousands of users and groups is super helpful because enterprises are really big. So yeah, I like absolutely have to mention Bloodhound because it is a tool that like everybody uses. The other like quick thing I want to go over, because this really deserves a lot more time, but I have 4 minutes, is lateral movement. So the idea is, let's say I have a TGT or NTLM ability to authenticate to some machine. How do I turn that authentication into remote code execution? There's a bunch of things we can do, right? Since we can basically arbitrarily read and write files over SMB. One is write a file over SMB and start it as a service. That's psexec. There's Windows management instrumentation, which we can authenticate to and do something where we can like create processes. So that's wmyexec. That's a common technique. We can modify an existing service to point to command.exe and then set the file descriptors to a network pipe instead of like a pipe on the host, and then connect to that and get a shell. That's SMB exec. Then my favorite is where we utilize the service control manager to go change where a service is pointing to while it's running to run some other executable. That's a really fun trick. You can find all of these on like GitHub or as part of the Impacket suite, and they're fairly simple to go run as long as you have, again, the authentication material. So, and if you want to run those Kerberos attacks before, guess what? They're really easy. There's a cool tool called Rubius. You pull it down and you just run rubius.exe Kerberos. Boom, Kerberos everything. You want to ASREP roast? Type ASREP roast. That's it. If you want to create a golden ticket, you just grab, I know the phrase AES256 hash is really weird. That's what it's called, strangely enough. But you can create a golden ticket if you have the Kerberos ticket granted ticket secret, and you can do it with RC4 for like the NTLM hash or the AES256 one. And that's how you make a golden ticket, which is not too bad. There's a trick you can do called overpass the hash, which lets you turn an NTLM into a TGT. Because NTLM is legacy, you can't do the opposite. You cannot turn TGT into NTLM, to my knowledge, but you can turn NTLM into TGT. And then, yeah, we can also use pass a ticket, which is where if we have a TGT and we want to immediately get the ability to have whatever access it is, that's what turns it from like you have the ticket and can present it to we're using the ticket. So that's like a whirlwind tour of how Rubius works. But if you understand the theory, using this tool is not very complicated. The one thing I was going to say before you guys start Kerberosting Illinois.net is there's a lot of protections for these. If you're skilled, you can get around each of them, but you need to know all of them. So Kerberosting will generate a 4769 event, which is normal for requesting a TGS. But if you have a honeypot service that's like looking, and nobody else is ever authenticating to it, and you see somebody gets TGS, gets TGS, gets TGS, gets TGS for a honeypot service, right? That's a dead giveaway that somebody is Kerberosting you. ASREP roasting will generate a 4768 event with RC4 encryption type and a pre-auth type of 0. Now, this is sort of up to the defender's discretion, but RC4 is old, and there are some cases where that's normal, but this is one of those cases where it's not. So anytime you see a 4768 event with RC4, it's not a guarantee something bad is going on, but it warrants at least a little bit of looking at. The other thing is Rubius, if you're just going to go rip it off of GitHub and start attacking things, will send randomly generated domain info because it doesn't need to have the actual domain or username or password when it's doing this. So it'll just send the domain out to something like that. That's a problem because that is very obvious. That's not the domain you're on. You can like pass these with command line arguments to go change that to be something sensible, but you need to keep that in mind. The last thing, and this is a little more advanced, is if you have an EDR solution on there, say CrowdStrike Falcon or Microsoft Defender for Endpoint, and they see you have some weird process that's making a bunch of Kerberos requests, like, let's say you're running malware.exe and you're sending out a bunch of Kerberos requests, or you think you're sly with it and you've injected into Microsoft Edge and you're like, I'm hiding. And then your browser starts making a bunch of Kerberos requests. It will generate this event, Kerberos activity from an anomalous process. Now, you would be forgiven for thinking that is just an event, but that is the name that they will give when they say CrowdStrike Falcon has killed your beacon, block that thing off the network, and initiate a live response. You will get insta-burn if you do this for real on a real network. without knowing how to get around this, which I won't go over for a while. So yeah, that is your motivation to not go Kerberos to Illinois net. The last thing, and I went over this before, is if you get into the domain controller, steal the ntds.dit, get the Kirby TGT password hash, and then you can go make a golden ticket. And you can set your expiration time. I think you can make it forever. The typical one is just like 10 years. That's long enough. And do that. And of course, you have domain admin. Well, guess what? If your security products are managed through Active Directory, you can just log in and start changing them, turning them off, deleting, various essential components. That's pretty easy. Just go turn all that stuff off. So yeah, and then golden tickets are awesome. I already went into them, but they're like a skeleton key. It lets you get into anywhere, like no conditions, full power. And you can do it with Rubius. I think Impact has one as well to go generate that. So yeah, the last thing I have to say is, now that you know how to abuse the cryptography of the golden ticket attack, try to avoid creating new domain admin accounts if you compromise a domain. These are really noisy. You can get away with it. Like, I believe there's a scenario where the Air Force got hacked, and they had like a bunch of domain admins, and the Russians just made like a bunch of new domain admin accounts. And then, the genius way of going and fixing this is they went through and asked all the domain admins to show their valid form of ID to go remediate these, right? So, you can get away with it in practice, but it's best to be avoided. Attack the cryptography instead. Okay. And this is just the tip of the iceberg, right? There are many, many, many more attacks, to the point where this is probably maybe 5 to 10% of the total things you can do in Active Directory. It's like its own category. We have Rev, we have Pwn, we have Web. AD is its own thing. So the stuff I'm going to cover later is delegation, DACL abuse, service for user, the certificate services, which is our public key cryptography, MS SQL, the group policy, and the configuration manager. And then, of course, anything you do for Windows will apply to Active Directory. So it's always important to keep that in mind foundationally when you're deploying malware and such on these endpoints. All right. So as you can see, now that I have a captive audience, lots of Active Directory, because this is the piece of software to go after. So yeah, that's pretty much everything I had for today. I know it was kind of fast, because I would try to go over, I think it was 52 slides an hour. But do you guys have any last questions? I know this stuff is complicated. It's complicated for everyone. Doesn't matter how advanced you are. But no, awesome. Yep.